Hi, and welcome to my presentation on metadata structures for two different biology repositories. For this project, I looked at two different examples of specialized repositories to look at how metadata schema can be adapted to the needs of an individual project. Both repositories focus on information about animals and living things. The first repository I looked at had a lot in common with our own project of user-contributed football images. Smithsonian Wild project collects images from camera traps and then uploads them to a central repository, and much like our football images project, the goal of metadata management is to have all the indexing done automatically or by the contributors, so that by the time the image goes into the repository, the metadata is pretty much finished and doesn't really need to be managed by an expert. And the project is about 4 years old, and as I said before, the goal is creating an on-the-fly repository. From a metadata standpoint, this is a really interesting project because it gives you some idea of the importance of consistent metadata practices, problems faced in the initial stages of repository development, and problems that arise as the project grows. This project was begun in 2006 and expanded to include projects in 9 different places by 2009, which means that there are 9 different teams collecting images from these motion cameras, each with their own metadata schema, each with their own digitization standards, so there's a lot that was not consistent initially. For me, this has been the most interesting part of the project in terms of standards. Standards were not given consideration early in the project, so it was necessary to create crosswalks for metadata from 8 existing projects. Fortunately, the nature of the images means that the same kinds of information were collected for each image, so metadata could pretty easily be crosswalked using a spreadsheet. Oftentimes they had the same elements, but they were called different things. There was rarely a case of completely different elements or elements that kind of straddled the line between 2 elements in the desired schema. Most of the left side elements they just adapted from BPI, which is what one of the camera traps in Panama was using. So they just took a project that they liked their schema and said, okay, we're going to adapt everyone's to meet this. Digitization standards vary according to the individual project's equipment. A lot of these projects are financed with grant money, so they can't really be picky about how many DPI or the resolution of the camera or anything like that. Another interesting aspect to this project is that all photos are included regardless of image quality in order to preserve these near video sequences of animals moving across the camera. So we really need to have metadata that describes the relation between images, because often a group of 4, 5, or 6 images gives a lot more information than one standing alone. So under the hood, this is not oyster compliant. That wasn't really the goal of the project. It's a very, very specialized metadata project, so the standards are not tailored for oyster compliance. They're tailored to suit the researchers and scientists. Many of them are very, very specific, things like what kind of bait was used to entice the subject to the camera, so this is not something that an average user is going to need. It's the scientists putting this project together that need that information. And it's actually all based on the Flickr API. So it's a Flickr-based application right now, and the plans are in the works for a more sophisticated database, probably focused on Drupal, like many of these other repositories we've looked at. Encyclopedia of Life is another Smithsonian project, and it was actually suggested to me by the technical team for Smithsonian Wild as an example of a highly effective metadata structure. An interesting part of this project is that the emphasis is not so much on creating and organizing original content, but on locating and indexing content from external sources. So rather than managing their own internal metadata, what they do is write metadata standards that other people can then use so that their search engines can go out and find different information and bring it together. And this is a data and image repository that brings together information and images on 1.9 million species from places all over the web. And what this gives us a look at from a metadata standpoint is how data is harvested, how standards are put together so that data can be found, left side elements specific to a certain discipline, and then the integration of several different schemas for classification of species. This is also a fairly recent project, started in 2007, and where they're hoping to go with this over the next couple of years is to digitize all relevant biodiversity literature. They truly want to be an encyclopedia of all living things. They hope to generate educational materials for schools and then create what they call synthetic knowledge about the world's biodiversity. It's interesting the shift here from we want to give information, or we want to create information and make information. They don't want to create anything new. What they're saying is we can have new understanding based on putting together content that's already out there. So the focus here is not on creating and organizing new content, it's on bringing together and organizing existing content so that they can be seen side by side and actually increase understanding that way. There's a biodiversity informatics team, and they work with the content partners for data harvesting. So what they're looking for are various data objects scattered all about the web. So if they have a page on one particular species, they want to run off and get a paragraph about what it is that a marmot eats, and they're going to grab it from another website. So it needs to have specific metadata so that their site knows that this is the part about what marmots eat. The site content's hosted by Drupal, and then it's aggregated using a variety of different programs. Their metadata standards are based on some existing structures, such as the taxonomies of living things that already exist, and then they also integrate schema for descriptive and technical metadata information about where the images and information come from. What is really, really interesting about this project, and what I was most fascinated by, was this nesting metadata. Because of the various groupings of information, the way that it's organized, there are different structures for organizing their data. There are pages that describe groups of species, so whole kingdoms, phyla, classes, and so on, giving the general characteristics of the group, but some of that information is very specific, including nucleotide sequences, in other words, what genetic markers show up as a characteristic of this group, and the various names and taxonomies within that group. Then there are individual species information pages. So for example, there's a page on marmots, and then there's a page on yellow-bellied marmots that gives you the same data fields above, and then tells you about the organism's habitat, its conservation status, its life cycle, its behavior, all of these different aspects of the species that can be described. So the animal is described using a metadata structure, and then the data that gets pulled from other websites needs its own metadata structure. So these individual data objects, which are paragraphs or images from other places, they have their own metadata. And this actually looks a lot like a Dublin Core record. It gives the author, the supplier, the rights holder, any licensing information, and the source URL of the places where their search engine has gone to grab things and bring back to their website. So, taken together, these two repositories offer a look at very highly specialized metadata structures that are built specifically for their projects and for their users. We began the semester talking about how metadata can add value to digital objects by making them findable and usable, and adding this kind of specialized metadata to information and images in the collection meets the very specific, often scholarly needs of these users. One of the biggest differences between this type of repository and some of the other image repositories we've been looking at is that we're cataloging two different things. We've got to have metadata information to catalog the image or information itself. That's these packages, information packages that we've got to describe. And then we also give information about the animal that's shown in the image. So we've really got two different things that need to be cataloged. And these metadata structures then need to be very tailored to the specialized nature of the repositories. I hope you've enjoyed this presentation. Please check out the screencast for more information. Thank you.